technology. But you'll really enjoy hearing from him from the engineer's perspective within one of these big multinational corporations, which I would argue is the most successful in engaging emerging markets. So that'll be a lot of fun. You guys are all going to be part of term-long team projects. So you're going to be in teams of 4 to 5 students, plus a mentor who's going to work with you. Throughout the semester, you are going to develop a new technology into the stage of like a proof of concept prototype that satisfies the design requirements you lay out. And you're going to collect data that actually validates the performance of that prototype. You each will have $5,000 budget for your team, and your purchasing can go through Michael. It can also go through our admin, Kaki. We'll work out what works best. You're going to present the progress of your project through 4 milestones: a strategy, concept, most critical module, and then final presentation. You're going to be designing with partner companies, not for them. You'll be interacting a lot with them. That's a big part of this class. And one of your things that I want you to do tonight or before the next class, please read through the syllabus, because I talk about all this in more detail. So I'm going to give you a quick rundown of this year's projects, but then next class we're going to do a more comprehensive rundown of like what the elements are of each of the projects we're going to be doing this year. And then after that you're going to be picking your project teams. But the reason I'm doing this today is Angie's going to come in a bit, in a few minutes probably, and talk in about 15 minutes, and talk about the specific resources that the library has for each of these specific projects. So the first one is we're working with Tata Motors to redesign elements, and we'll see where it goes, but elements of the interior or engine mounts or whatever to reduce noise and vibration in the passenger compartment. It's one of the big issues of this car. And how cool is this? We have a Nano. So we just got this. This is Natasha, one of my grad students. And if you guys are greedy, we're actually getting another Nano this week. And if you're really greedy, we'll have a third one too. So these 2 guys are getting air freighted right now. I think tomorrow they're flying from India. So they'll be here soon. But this one's parked out behind my lab. So how cool is that? You're going to get to play around with the Nano. And Michael is going to set up a autocross course so we can whip the Nanos around. My lab's over in E34, which is by the medical center, and you know the big medical center parking lot? So we'll do an autocross course there one night this semester. So you guys, and then the Tata team can play with these. So that's one. The next one is that reverse osmosis, which is a means of getting salt out of water, is all the rage in India. India has a lot of salty water. You're going to learn about that. And Tata has just launched a line of reverse osmosis systems. But we're working on some research that uses a different type of technology. It's called electrodialysis that pulls the salt out with an electric potential. And we're seeing that we can recover much, much more fresh water out of the input water, upwards of 90%, rather than reverse osmosis, which is closer to 40%, 30 to 40%. So these guys are pumped about the market opportunities. So what this project's going to be doing is looking at the feasibility of shrinking down electrodialysis, which is done on bigger scales right now, to a home use system, right? And we have reverse osmosis systems you can play with right now, as well as electrodialysis systems in the lab. We're working with one of the biggest eye care institutes in the world, LV Prasad, which is also in India, and they want to develop a product that enables people to have magnified vision both at short and far distances. This is a big problem that affects about 50 million people, like elderly and people who have like blurry vision. And the products that are out there now are like, here's this reader system that uses a electronic camera to magnify the text of a book, but this lady can't look at a like a blackboard. Right? Think about a kid sitting in a classroom. How's he going to do this and then that, long and short distances? Here's another book reader. Here's a long distance vision system. So we're going to try to engineer a single system that can do far and near vision, which will be pretty cool. And I've got all sorts of toys. I'll bring it next class that go along with this project. You can see existing products that are in that space. We're also working with Ferrari. So what's Ferrari have to do with emerging markets? Well, a lot, right? A lot of Ferrari's business is in Asia. They're selling a lot of cars to China, so they really care about emerging markets. And they're at the cusp of where they have to make like a lot more efficient cars. You know, emissions restrictions apply to them, just like economy cars. And so what we're going to be working on is a next generation hybrid transmission with them that has the electric motor packaged within the transmission. I'm sorry we don't have a Ferrari 458 here for you guys to play with, but we do have a transmission. So this is the transmission. This is sitting over in my lab. This is the transmission from that car, which is pretty cool. So you guys are going to be able to rip that apart and see how it works, and see how you could redesign it. And then we're also working with a huge fishing manufacturer, fishing equipment manufacturer. I love fishing reels because they're pure mechanical products, right? They're really intricate, nicely designed mechanical things. And Okuma sees a massive market opportunity in Brazil. But to engage that market, they need to make this reel a lot cheaper, about 50% cheaper. So what we're going to be doing is design for manufacturing in trying to get cost out of this. But I like, there's kind of a biblical aspect, like teach a man to fish thing in this project, which I like. This is going to be a lot of fun. And then the final project is with Usha, which is a big consumer products manufacturer in India. And they make fans. They make ceiling fans. And the big opportunity they see is that if they could come up with a way to make people feel as cool or almost as cool as they would with air conditioning, but by forcing air, just blowing air around a room more efficiently. Hey, Angie. There would be a massive, massive market for this. Because I just took this picture out of an Indian apartment complex with all these air conditioners, sucking power. It's a big grid load. Imagine if you can design some system to move air around where you target where it's pointed at a person. Maybe you add humidity to it. I don't know. We're going to look. You could tap open a massive new market. So as cool as AC, but with less power is kind of the mission here. And I put this picture up because ceiling fans draw hot air from the top of the room. They're placed close to the top of the ceiling, so it's kind of stagnating in the flow. There's a lot of room for improvement here. I want to give you a couple examples of last year's projects so you can kind of get a sense of the scope of what we're looking for. So one of the ones that I really liked last year was the bulky truck project, which was done with Mahindra. And Mahindra actually has another good project for us this year if we end up needing to do another project in the class. But anyway, their smallest tractor is 15 horsepower, and it's only used for less than 5-acre farms. Turns out there's 2.5 billion farmers, with a B, around the world that farm less than 5 acres, right? So massive, massive market opportunity. And so these guys are using pack animals right now. And so you don't get the power output or the efficiency, farming efficiency of the tractor. So we wanted to look at, how well could you do with a little tractor. And the name of this project is Bull-Key because these things are called bullocks, these oxen type things. What unlocks a bullock? A bull-key. So we wanted to generate a high traction with low weight system. And they gave us this, you don't have to read through this, a whole bunch of design requirements. But the big one is that they wanted a 350 kilogram device that could pull, they wanted upwards of 300 kilograms of force. So we wanted to see, is that even feasible? So what this team did is all the market research, probably from Angie's website partially, like where she got tractor information, but all the market research on how much a tractor weighs versus how much it can pull, and found the trend line and saw that, boy, 200 kilograms pulling force looks reasonable. 300, maybe not so much. Then they did, worked out the theory behind how much traction can they get as a function of tire geometry and soil type and everything. They did bench level tests, and then they actually ended up making a little tractor that has the right weight and right weight distribution that Mahindra wanted. And then they validated it. And the big punchline here is that they found that they can only pull about 200 kilograms drawbar with a 350 kilogram machine. And Mahindra saw this at the end of the semester, and they were like, holy cow, this is so valuable to us. Because we had already started just designing a new product under the assumption that we could get more traction. We actually didn't know the limits. And so the moral of the story here is, even though these guys didn't create like a whole new finished tractor product, they created a chunk of information that was massively valuable to the company, right? And so this is the scope of stuff that you can do in the semester. They also wrote a paper for the big ASME design conference, which is the final deliverable for all of you. Another one we did was trying to make a low pressure drip irrigation filter. So we could have like a gravity fed irrigation system goes through a filter, and we want to minimize the pressure loss through here. So the moral of this story is that you typically use screen filters in irrigation systems, where it's just like a cylinder of a screen, like mesh material, and it gets sand out and stuff. And we were working with IDE on this, International Development Enterprises. So here's one of their filters. And what the students did is looked at the physics of the problem, realized what determines your flow rate as a function of pressure. It all depends on your filter area and the permeability and the viscosity of the fluid and the length and stuff. But the place where you can get some freedom here and get better performance is by increasing the filter area. So you look at this like little cylinder screen versus a pleated pool filter, you get mega more area here. More flow rate, less pressure drop. It's a big win. And so they characterized the performance of these filters in irrigation systems, looked at as you dump sand in, it actually gets more and more restrictive. And then they actually came up with a design to allow the sand to dump every time you turn off the water, and it would collect in this reservoir here. And they were able to get like a pretty constant resistance filter over huge sand loading, 2.5 kilograms sand loading. So IDE was like, this is awesome. We had not thought about using a pleated filter. This is used in swimming pools, but there's no reason you can't use it in irrigation, right? So again, an example that in a semester, with your background, with your engineering knowledge, with the context from the partner, you can make an impact on these organizations. As far as fabrication facilities, we don't have a dedicated shop space for this class. So you're going to need to seek out fabrication spaces, and there's a lot of them around. Hobby Shop, Edgerton Shop, your offices, you can store things, Grad Shop, L&P. My lab has a full machine shop, and if if you're working in the lab and you have somebody from my lab on your team, or a few of the mentors are members of my lab, you can certainly go in and use it. Just make sure you're working with somebody from my group. I don't want people just waltzing in to the lab and like taking tools and stuff. Michael's going to be your point of reference for fabrication. He's your guru, and you will make shop guys so much happier if you just always leave shops clean, cleaner than when you found them. The final report for this class is a draft paper for the big design focus conference put on by ASME. This is the biggest design focus conference put on in the country. And the timing of the class works out perfectly, because the end of the semester you'll have a draft. I'll give you a load of feedback. You do one revision, boom, you submit in January. And last year, 4 of the teams submitted papers to the conference, 3 got in. So that was pretty cool. It's publication for all of you. So I've put some examples up online. These are a couple that I've done. And then I put some up from last year as well, the ones that got accepted, so you can see those for reference. But as far as the major sections of the paper, you have to remember is that you're going to need a background and motivation section. This is, by the way, from one of the papers up there about our wheelchair. So, this is showing some prior art, and what's up with these prior art products. So you're going to need to motivate your problem. You need to do that background research. That's why Angie's here, because she has lots of resources for you. And then you're going to have to do a bunch of analysis. So this is like power analysis for our lever-powered wheelchair system. You're going to have to do a materials and methods, like the experiment you actually ran, how you ran it, data you took, and you have to do results and analysis. And then you're going to need some broader impacts and ramifications. So, talking about like what do your conclusions mean? Why do they matter? What future work may you have? And I spell this out in more detail in the syllabus, each of these sections. So you have example papers on Stellar. Angie's going to come up in a second. Is going to talk about your library guide. And so, I think all of you are going to make some really nice outputs in this class. You're going to make a new technology. You're going to advance your partner's capabilities. You're going to get a publication, most likely, particularly if you want to go ahead and submit the final publication. And you're going to get all sorts of great perspective about being a global engineer. So I'm excited about this semester. We're going to have a lot of fun. Here's a grading breakdown. It's very heavy on your presentations that you do with your teams. So all of these are graded by team. And then as well as the product take apart that we're going to do. And then as is your final report. And then you're individually assessed by peer review, by your mentor's assessment of your performance, and by class participation. That I see in this class, and you coming to class, your attendance, all that stuff. So that's broken down in more detail in the syllabus as well. And finally, your first assignment is, we're going to go into design process starting next class. So I want you to read over the next week the Human-Centered Design Toolkit. It's kind of a long document, so I'm giving you a week to do it, as well as this short one-page article, which is cool because it's by one of the most preeminent scientists in the country, kind of throwing down the gauntlet and saying, we need research in developing countries. We need hardcore science and research. It's written by George Whiteside, so it's a good paper. Yeah, so and next week we'll talk about more detailed project descriptions, and you'll start picking your projects. So I'm going to hand it over to Angie. All right, that timed up perfectly. Awesome. 1:57. Do you want HDMI or?
Sure. No.
No, you don't. She doesn't. This is Angie Lochnar.
Hello.
She is our library representative for MECI. By the way, Angie's a person you should get to know, because when you're actually, it was a number of years before I actually met you in person, but as a grad student here, I'd email you all the time and be like, Angie, I can't find this thing. Like this paper or this topic, can you help me? And you'd email me help.
Yeah.
And then we met, and
Yes.
we became friends.
Because you became like this big mucky muck guy now.
No. I didn't get voted off the island yet. That's why I'm still here.
The mic?
Oh yeah, here. Why don't you take the mic? Here you go.
Okay, so this is my pocket. Take my keys out. Oh, and I need to, yes. There we go. Woohoo. All right, hello everyone. Welcome to the first day of class. So I'm going to just give you like an overview of some of the resources for this class. There's no way I could possibly show you everything you might possibly use, especially in the next like 25 minutes or so. So hopefully, if nothing else, you'll remember who I am. You'll remember that there are lots and lots and lots and lots of resources that the libraries can help you with, either online or actually there are some in print still you might want to use. And I'll just jump right into it. So as Amos said, I'm the librarian for mechanical engineering. I'm also the librarian for materials science and engineering and the engineering systems division. So I kind of know a little bit about just about everything, which makes it good and also kind of bad, because I know where to get you help if I can't do it. But I know a lot. So, or you can test me on that, but yeah. Hopefully,
Well, if people
we
are
can help
feeling
you.
tired, by the way, you're welcome to the Red Bulls on the table. I think Red Bull put them there. I didn't put them there. But I think they're safe.
So they're just magical, random
Yeah,
Red Bulls.
somebody drank
Sure,
them
drink those
early
up.
on, right? Yeah, and he doesn't look dead. Okay. Here's the canary.
Okay, so before we jump into the guide that I created for this class, if you haven't looked at the library's homepage yet so far this year, you'll notice it's totally different. So I just wanted to put it up there. We redesigned it. Hopefully it'll be easier for you to use. If you have any questions about it, send them our way. But I'm just going to go, if you go down, I'm going to go to all the guides to find the guide for this class. But you'll have the link on your Stellar page, so you won't have to go through this process. Okay, so let me make this a little bigger for you. So this is a guide I created for this class. Again, this is just kind of a taste of things that you might be interested in. It's no way going to cover absolutely everything that you might possibly want to do. And there's lots of information on this page, even considering the fact that it's not everything. There's still a lot here. Before we even leap into any of the resources, first thing I want to point out is this box about managing your references. I cannot stress enough how important it is and how thankful you will be if you pick one of these tools before you start your research. And we don't really care which one you pick. They all kind of do the same thing. What these things do is they'll grab all of your citations, store them in a database of some kind, and then as you're writing with a couple clicks, you insert citations and format your bibliography, And you don't have to know anything. Like, where does the comma go? Is this really italicized? It doesn't matter because the software does that. And with tools like Zotero or Mendeley, those are both free. Mendeley is much better at having a big file of PDFs. So if you're working in your teams and you want to store all of your PDFs together and annotate them, Mendeley might be the way to go. Zotero, you can also set up group folders. Some people use them both together. Just to give you a taste of how awesome these things are if you haven't used them before. I'm going to just demonstrate Zotero. So I'm writing my paper. It's the end of the semester. I got to do my ASME deadline. As you can see, I'm very informed about my topic. And as I'm writing, like, oh, okay, well, here's a statement that really needs a citation. All you have to do is put your cursor where you want the citation to go. And then for Zotero, you go to your add-ins, and all these weird little symbols are Zotero. If you hover over them, it kind of tells you what it is. So this one says, do you want to insert a citation? I say yes. First thing it's going to do is ask me which format I want the citations in. ASME, because we want to present an ASME paper. So I say that. Now it's like, well, which citation do you want? And if you remember, oh, the author's name is this, or I know the title has something to do with that, you can type in some words here. Let's see if anything comes up. And then it'll pull up any citations that you have. You select it, and there's your citation. So here's something else that's cited. We'll just do another example quickly. Citation goes there. We want to add something. So this time I don't remember anything about the citation, but I know I put it in a certain folder. If you click on the Z and go to the classic view, you can just see all of your citations. So I could go in here, and I don't think I have one just for this class, do I? No. I'll take one from DLab. So you find your citation. Ta-da, it's done. All right. So you're done with your paper. Now you want to add your references at the end. Again, you go up to your toolbar, and one of the middle ones says Insert Bibliography. So you select that, and there's your citations. Okay? So you're like, yay, done, hooray. And for some reason, ASME is really like particular, and they decide not to accept your paper at ASME. So you're like, well, fine, I don't care about ASME. I'm going to have this go to IEEE instead. So, no, not IEEE. I'm going to send it to the American Medical Association. So you can just go in here. You can change the citation to wherever you want to send it. And it's going to reformat all your citations. So again, you don't have to remember any of that stuff. And I always want to point this out really quickly because, as you can see, it's really easy to use. It's really easy when you're online to grab all the citations and throw them in there. You should never have to cut and paste. So pick one of these. I think you prefer Mendeley in your general life, but
yeah, it looks like you're using Mendeley.
Yeah, but any one of them is excellent to use. Are there any questions about that before I gloss over some other things? Okay. So yes? If you look at any of these guides, all of these links take you to like, how do I get this and how do I use it with resources? There's always going to be a tab for how to use it with LaTeX or BibTeX. So they should all work with those. Okay, so on the course guide, I'm going to start at the very bottom. Just to point out, handbooks and encyclopedias, this is often something that people are like, meh, I don't really need to know that. I know everything already. But handbooks can be really useful to get really quick facts. Also, some of your recommended readings, I believe, are listed here if it hasn't changed much from last year. And this might also be a way for you to get up to speed on a topic. So if you're working on, say, the ceiling fan project, and you want to learn more about how the body regulates temperature, you can go into comprehensive physiology and see a whole chapter on how the body regulates temperature. Or for those of you working on the project about vision impairment, you might need to learn more about optics. So you can go into the optics encyclopedia. So there are lots and lots of examples. I'm going to show you Novel really quickly. Has anyone here never heard of Novel? A bunch of you? Wow, look at all of you who've never heard of it. Okay. So Novel is a big collection of handbooks and different types of reference materials, and it searches the full text of them. So if what you're looking for is on page 250 in paragraph 3, it's going to show that to you, which is unlike a library catalog, which will just tell you, hey, that book is the words in the title. So for example, I just looked up a fishing reel just to see if there were any books that mentioned a fishing reel, and lo and behold, there's a book right here. What the results show you is this is the section of the book that talks about whatever you're looking for. And then down here is the actual book. So if you wanted to see if we have a physical copy of this book, you could look up Design for Manufacturing, a Structured Approach, and go pick up that book. Or you could read it right here, because it's online. And if we go to this section, you'll see that this is actually an example of how they selected materials for building a fishing reel. So this might give you ideas on how you might want to go about that process. And you can see like what their schematic drawing was and which different tables they checked to figure out their calculations for different material types. Okay, so that's just like searching novel like you would search anything else, where you're just looking for terms in a PDF. There's also something down here called the data search. And this is where you can actually search for material properties buried within, hundreds of pages of tables within these books. And you don't have to then flip through the entire table to find the one thing you're looking for, because Novel will pull that out for you. So for example, I'm just going to look for something. I'm thinking about optical properties, and I want to look for a refractive index. So if you start typing in the property on the side here, it starts limiting your options on the side. And I see, oh, here's refractive index. I'm just going to grab it and drag it to the middle. And then it wants to know, like right away it says, well, there are 131 different instances where someone's talking about a refractive index. That's not really good enough. I want to be more specific. So I'm going to look for a refractive index that's between, this is one of my favorite features. It actually gives you the range, because for someone who's not an engineer like me, I just start randomly throwing in numbers and it never works because I don't know what the parameters are. But now I do, because Novel's helpful. So I'm just going to put in 2, 2, 4. And as you enter that, you see now my results are back down to 77. So that's less results. And again, when we look at this, you're going to see the name of the table where that information appears, and you'll see the title of the book. I'm not really interested in lithium niobate, so I'm going to scroll down a bit, see what other titles might be here. Oh, and here's one on building scientific apparatus. So I'm just going to look at all these characteristics of optical materials. And instead of just giving me the PDF, it has pulled out only the substances that fit what I searched for. So I don't have to go through all of those pages. It's just a way to save time. And then you can export this or whatever you want to do. Are there any questions about this? Okay, I will go back to the class guide. And I'm going to scroll up a little bit. So the next box up is all about finding information about your customers or your clients. So the projects are assigned to companies. You might want to learn more about that company. So when you meet with your person, you can be like, hey, I just saw in your quarterly report that, they get very impressed if you start talking numbers to them. And there are lots of ways you can find information out about companies, especially if they're publicly traded companies. Private companies are a little harder because they don't have to report lots of information, but there's still ways around that. I put a few links here, but there are guides dedicated just to these topics. So if you just want to learn about companies, there's a guide just on all of the different ways you can get information on companies while you're at MIT. The same is true with industries. So if you need an industry report, if you just want to see what is the automotive market looking like these days, you can go to some of these big industry reports and get kind of a big sense for the picture of that particular industry. And there are more specific links here. There's also information about countries. So for example, this World Development Indicators Online, that has just lots and lots of data. So if you wanted to know what percentage of roads in India are paved, you could go in here and find that out. And that might be useful for you if you're designing something, if you think, oh, everybody has paved roads, and you find out that only like 20% of the roads are paved where you're working, you're going to need to rethink your design. And there's lots and lots of other factual and data links in here. Again, if you aren't finding what you need, please ask. If you spend more than like 20 minutes trying to find something, just stop and ask us, because we might go, oh yeah, it's right here, and you've just spent like 3 hours Googling randomly, hoping that you'll come across it. There are lots of ways to get help, as long as I'm on the subject, so you can always contact me. My office is actually in Hayden Library, not in Barker, but odds of me actually sitting there when you need help are pretty slim, so I wouldn't just show up hoping that I'm there. You can always email me. Or if I decide, after this week, I'm like, oh, that's it, I need a break, I'm taking 2 months off. You don't need to wait for me to come back. We always have these services called Ask Us. You can fill out a form, and this is for like any information need you might have. We have librarians that screen these questions that come in Monday through Friday. And we also now have a chat service. So as you can see, chat is online right now. So if you just have a quick question, you can jump on and be like, hey, do you have this book? And get an answer, and you won't have to wait for me to get back to my desk and check things. Okay. Now, if we scroll to the top box, this is where you can find lots of different articles. And for the most part, these aren't going to be searching the full text of the article. They really only search the abstract, the article title, the journal title, the authors. So you really need to think carefully about what you're searching and try and think about, well, how would this be described in the abstract of this article to really find those particular items. I'm not going to demonstrate these because they're all pretty much, you open it, there's a box, you put stuff in the box. I'm sure you can all figure that out. I'll just mention a couple. So if you haven't searched Compendex or Compendex and Inspec before, you should if you're engineers. Compendex is the place to go for engineering literature. It goes all the way back to the late 1800s. So if it has been published and it's about engineering at all, you should be able to find a citation for it in Compendex. It's teamed up with Inspec. Inspec covers physics in every aspect of physics you can think of, but also electronics and computing and control and robotics. So if you're searching them both at the same time, you're going to cover a lot of information. I'm also going to point out, since there are a couple automotive projects, we do have access to the SAE Digital Library. That's the Society of Automotive Engineers. But we only have access to the full text of their papers from 1998 forward. But we do have pretty much anything they've published in Barker Library somewhere. It might be in a book, it might be in a journal, it might be in microfiche, but we have it. So if you're searching the SAE Digital Library, you don't get a PDF when you're in there. Just either go to Barker or contact me and say, hey, I need this paper, and I will help you navigate and figure out how to find it. There is a guide to try, if you really want to try and do it on your own, you can do that, but SAE is just one of those societies that they don't publish their papers in one way. They publish a paper and it might be in as many as 5 places at once, or it might be just be in one place, so it gets a little crazy. But they have a lot of great stuff, so you should definitely check that out. Okay, are there any questions about anything I've talked about so far? I'm doing pretty good on time, proud of myself. All right, so last thing I want to talk about is over on the side here are some other guides that might interest you. So for example, you might need to look at different standards, maybe on how to test something, or maybe if you're building something, it might fall under some certain standards. We have a guide for standards. We do have the ASTM standards all online, so you can get to ASTM standards online. Anything other than that, we have a kind of purchase on demand program. So all you have to do really is, if you want a standard, go to this link and fill out a form, say, hey, I want this standard. And then librarians like me will check our collection, see if we actually have it in print. And if we do, we'll say, hey, that's in print, here's where you find it in Barker. If not, we buy it. So be careful, like don't just go, oh, I might possibly want some of these at some time and just start randomly filling out requests. Because we do have a limited budget, and if you send lots and lots of requests, we'll ask you to prioritize them so that we don't spend all of our money on you, unless you really need it, in which case we'll work something out. But definitely if you need a standard that we don't have, we'll do our best to get it here for you to use. And the other thing I'll talk about are patents. Again, we have a guide for patents. There are tons of ways you can search for patents. And it's really up to you which place you'd like to go. Most people just jump to Google Patents because that's easy. If you do that, there are a few tips you should think about when searching for patents. I'll just show you in Google Patents, assuming that that's what you're going to do. So let's look for a ceiling fan. You typically want to search for patents based on what the device does, not necessarily what it is. So ceiling fan may not actually be the best search, but we do get some results, which is great. But what you should do is take a look. Let's see, let me pick. Oh, I'll take this first one. No, I don't want a remote control. Here, I want one about the fan blades. So when you look at the actual patent, one thing that I don't like about Google Patents is it buries all the good information at the bottom of the record. So if we go all the way to the bottom past everything else, that's where you can see, what other patents does this patent cite? So, what patents was this patent based on? And the smaller the number, the older the patent is, which can be kind of fun, like tracing things all the way back. You can also see what patents cite this patent. So if you want to say, oh, okay, so since this thing was built, how many other things have been patented based on that thing? You can get a list of those. But what you really want to look for is way down here, the classification codes. So just like articles or anything else, any type of information that's organized,